Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have been solving algebraic equations, and we have been solving usually one-step equations. What we're going to do today is start looking at how you could solve some word problems with algebraic equations. We've done this a little bit so far, but we're going to touch on it more formally today and do some practice. Now, the thing about this is that you don't have to know algebra to solve these problems. They're actually pretty simple word problems. But the idea is to get you thinking algebraically, all right? To get you constantly thinking in that algebra form. So what we're going to do for each question is we're going to identify an unknown, and we're going to create and solve a math equation and answer in a sentence. So number one, Cape Scott has hailstorms 18 days per year. This is 11 days more than the number of days per year Edson, Alberta has hailstorms. How many hailstorms does Edson, Alberta have? Per year, I guess that should say. Now, it's not that hard to figure out the answer, right? Cape Scott has 18 days per year, hailstorms 18 days per year, and that's 11 more than Edson. So 18 minus 11 is 7. So Edson's going to have 7. But I want to think algebraically. I want to apply some algebra to this situation, even though we can get the answer by mental math. So first thing, let's identify the unknown. Well, the question says, how many hailstorms does Edson, Alberta have? That's the unknown, is Edson, Alberta's hailstorms. So let's say let X equal Edson's hailstorms. That's the unknown. Okay, identifying a variable for your unknown. Now what that means is in the problem, wherever you see Edson, that's going to be X. So it says Cape Scott has hailstorms 18 days per year. This is 11 days more than the number of days per year Edson has hailstorms. So 11 years more than, let's just think of Edson as X. Now what we want to do is write a math equation in the form that we've been using to figure out the solution to this problem. So we're going to go through the problem and look at key words. It says Cape Scott has 18 hailstorms per year. Well, let's start with that, 18. And it says this is 11 days more than the number of days per year Edson has hailstorms. 11 days more than. Well, first of all, is. That word is very often means equals. So 18 is equal to, and it says 11 days more than the number of days per year Edson has hailstorms. 11 years more than X. Think about how I could write 11 years more than X. Well, we know more than, if we think number operations, more than means plus. So how will I show 11 years greater than X? Well, I could show that as X plus 11. So what we've just done is we've taken this English language and we've created a math equation out of it. 18, Cape Scott's hailstorms, is the number of days Edson has hailstorms per year plus 11. Or what might be simpler to do is reverse it and have X plus 11 equals 18. And then we would just use our knowledge of equations to solve this. We'd do minus 11, and we get X equals 7. And we knew that answer already, but we're just applying some algebra to it. Now, X was what we called Edson. So Edson usually, because it's not always going to happen, right? Usually has 7 hailstorms per year. So that was an equation. There was a problem where we created an equation that had addition in it. And then we solved it by subtracting. That's the goal. And most kids can get the answer, but the goal is to try to apply some algebra to it. Let's do another one. So it says Carson shot -4 in his last round of golf. Wow, I need to get Carson to show me how to golf. This was 12 shots less than what Kerry shot. What score did Kerry shoot? Well, let's identify the unknown. The unknown is right in the sentence there. What score did Kerry shoot? Let X equal Kerry's. Having trouble writing today. Kerry's score. Now let's try to create a math equation out of this. We know Carson shot -4. We know his score. This was. Well, was is sort of similar to is. This equals 12 shots less than what Kerry shot. Less than. Less than is a phrase that signifies minus. So Carson shot -4. This was 12 shots less than what Kerry shot. So if Kerry shot X, 12 shots less than what Kerry shot would be X minus 12. And there's our math equation. The number of Carson's score is equal to Kerry's score minus 12. To solve it, do the opposite operation on both sides, but some people like to reverse it and write it like this. Might be easier to write it like that. So add 12 to both sides. Do the opposite operation, add 12 to both sides. And X equals positive 12 and negative 4 makes positive 8. Also an excellent golf score. But Carson is the winner on this one because he shot 12 shots less than Kerry. So Kerry shot +8 though, which is a great score. Kerry's score was +8. And I guess I should have, for you non-golfers out there, I should have clarified that the lower the score in golf is the better score, right? So Carson got the better score because you want to take fewer shots. Okay? Both of these guys would absolutely destroy me on the golf course, though. So again, another equation where you have to translate the English language into algebra language, and you're looking to try to make some of those common equations that we've been studying. Let's do another one. One number is 3 times the size of another number. The sum of those numbers is 24. What are the two numbers? Okay, this one's a little bit different because we've got 2 unknown numbers this time. But check this out. We're given a clue in the first sentence what they are. Well, one number is 3 times the size of another number. Well, let's start with the basic one. Let X equal number 1. And then it says one number is 3 times the size of the other. Well, if X is the first number, the second number has to be 3 times X, and we would show that as 3X. So let 3X equal number 2. Then it says the sum of those numbers, sum meaning add, is 24. So let's add these 2 numbers up. Let's add our 2 unknown numbers up. We have X plus 3X equals 24. And we already learned that when we have a variable with no number in front, no coefficient, there is a number in front. It's a 1. So think of this as 1x plus 3x equals 24. Well, 1x plus 3x is 4x equals 24. And now we have a multiplication equation. We solve those by dividing. Divide by 4. Divide by 4. 4 divided by 4 is 1x. 24 divided by 4 is 6. And x is equal to 6. Well, if we got x equal to 6, then we should know what the other number 3x is equal to. 3x will just be 3 times 6, and that equals 18. Now the two numbers we get are supposed to add to 24. 6 plus 18 is 24, and 18 is 3 times the size of 6. There's our two numbers. We could have gotten this guy by guessing and checking, but this time we got it by some algebra. The numbers are 6 and 18. So again, we're looking to try to make equations in those forms that we've been writing, in the adding form, the subtracting form, the multiplying form. Let's look at one more. For the month of January, the average temperature in Edmonton was 1/3 the average temperature in Yellowknife. The average temperature in Edmonton was -8, and I should have here degrees Celsius. What was the average temperature in Yellowknife? Well, let's start with our unknown. The sentence says it all. What was the average temperature in Yellowknife? Now that's a lot to write, so I'm just going to write let x equal Yellowknife. Now wherever it says Yellowknife in the question, that's going to be x. So right over here I see that this Yellowknife is going to be x. Okay, let's translate from English into algebra. For the month of January, the average temperature in Yellowknife was 1/3 the average temperature of x. 1/3 of x means x divide by 3. And it says the average temperature in Edmonton was 1/3 of x. So if you take 1/3 of x, you will have the average temperature in Edmonton, which was -8. And there you go. There's another math equation in the form that we've been studying. This one's the division form. To solve it, multiply both sides by 3. Just like we've already learned. 3 divided by 3 is 1x equals 8 times 3 is 24, and it's different signs, so they're negative. X is equal to -24 degrees Celsius. And that means Yellowknife's average temperature was -24 degrees Celsius. So, we solved an equation where we had to translate into a division equation. We solved an equation where we had to translate into a multiplication equation. This one we had to translate into a subtraction equation. And this one we had to translate into an addition equation. In the assignment I give you today, I'm going to give you 4 word problems, and there will be one of each. And I want to see if you can translate them from English into algebraic form just like these, and then solve them. I hope that helps. That's all for now. Flexing Teacher Weber out.